Now in this presentation, we are going to find the GCD of two numbers, as well as we are going to discuss how it can be extended to find the GCD between n different numbers. Normally, to find the GCD between any two numbers, we will be finding the prime factors of each number, and then we will find the common prime factors between those two numbers that are taken, and that will become the GCD of the given numbers. Let us take an example and see how we can find the GCD of those two numbers. The numbers assumed are 24 and 18, and as I said, we are going to find the prime factors of number 24 and 18 separately. The prime factors of 24 are 2 into 2 into 2 into 3. So it is 2 into 2 is 4, 4 into 2 is 8, 8 into 3 is 24. Similarly, the prime factors of 18 are 2 into 3 into 3. So 2 into 3 is 6, 6 into 3 is 18. Now, we are going to take the common prime factors between these two numbers. There are 3 2's in 24, but there is only 1 2 in the 18. So we have to take only one thing as common. So there is 1 2 as common. So it is prime factor, one prime factor between 24 and 18 is 2. Similarly, in 24 there is only 1 3, but whereas in 18 there are 2 3's. So the common prime factor for both is only 1 3, so it is 3. So the prime factors common to both 24 and 18 are 2 and 3. If you multiply these two, you are going to get the value as 6. And so the GCD of 24 and 18 is 6. Now if you want to implement this in computers, that also can be done, but it is cumbersome. That is, we have to find all the prime factors first, then we have to find the common prime factors between these two numbers, then only those prime factors can be multiplied and you can get this value. So it is a cumbersome process. Instead, we can use some simplified method. Let us discuss that method first, and then how we can do it in computers, that also can be discussed. Now, once again, we take those two numbers, 24 and 18. So you take 24 as numerator and take denominator as 18. You divide this 24 by 18 and find the quotient as well as the remainder. The remainder becomes 6. Now you are checking whether the remainder equal to 0. It is not. So now in that case, the previous denominator will be taken as the numerator now, and whatever is the remainder at present, that will be taken as the denominator. Therefore, 18 becomes the numerator and 6 becomes the denominator. And if you divide these two, 18 by 6, you will get the quotient as 3 and the remainder is 0. So in that case, you are checking whether the remainder is 0. Yes, it is 0. So in that case, whatever is the denominator, the previous we have used as the denominator, that will become the GCD. So here the previous denominator is 6, so the GCD is 6. So it is little easier to program rather than finding the factors, prime factors, and then finding the common prime factors and then multiplying those numbers. It's a cumbersome process. Okay, let us take another example. That is, suppose we have taken 18 as the numerator and 24 as the denominator, what will happen? Let us see that. So if you take that, now the quotient is 0. When you divide 18 by 24, the quotient is 0. The remainder becomes 18. Now what you have to do now? The remainder is not 0. So we have to take the previous denominator as the numerator now, and also the remainder as the denominator. So that is the thing. 24 and 18, you divide that. Once again, you get the remainder as 6. Now when the remainder is not equal to 0, So the previous denominator 18 is stored as the numerator now, and 6 will become the denominator. When you divide this thing, you will get the remainder as 0. So since the remainder is 0, GCD is 6. So it shows whether you take the biggest number as the numerator or the denominator, you are going to get the same result. Only thing is, if you take the numerator as the smallest number, you will be doing one extra computation, except that there is no difficulty, or we will be finding the same value. Let us take another example. So the numerator is 16,116. The denominator is 504. So if you divide 16,160 by 504, the quotient becomes 32, and also the remainder is also 32. Since the remainder is not equal to 0, you are taking the previous denominator as numerator now, and whatever is we got as remainder, that will become the denominator. So 504 by 32 will give 24 as the remainder. Once again, the remainder is not 0. So 32 will be taken as the numerator, and 24 will be taken as the denominator. Previous denominator is numerator, then the remainder is denominator. So 32 by 24 is, you are getting the remainder is 8. So it is once again not 0. So what you will do? So you take 24 as the numerator and this 8 as the denominator. If you divide that, the remainder becomes 0. So you are getting the remainder as 0. So we are getting the value as 8. So if by doing this repetitive operation 3 times, 3 plus 1, 4 times, you are able to get the value as the GCD between these two numbers. Assume that, suppose we want to find the prime factors of 16, 116, 0, how long it will take, as well as for 504 also, you will have to find so many prime factors. Then we have to find the common prime factors and then multiply those things. So it is going to be a cumbersome job. So therefore, let us use this method for computerization. Okay, here the algorithmic steps that are going to be used are: input the first number and store it as A, then input the second number and store it as B. Now store the value of A as the value of numerator, and then store the value of B as the value of denominator. Now divide numerator by denominator and get the remainder. As we all know, the percentage sign is used to find the remainder. We are not bothered about the quotient here. We are only bothered about the denominator remainder. So that is why use numerator percentage denominator. You will get the remainder now. Now we are going to repeat the steps 7 through 9 if the remainder which you have obtained in the earlier case is not equal to 0. If it is straight away 0, you will straight away come to the step 10. Whatever is the denominator that has been used now, so that will be stored as the value of GCD, and you will be outputting the values of A, B and CD. If the remainder is not equal to 0, what do you have to do? The previous denominator has to be stored as the new numerator. Similarly, whatever you have obtained as the remainder earlier, that remainder has to be stored as the value of the denominator. And then you divide this new numerator by the new denominator and get the remainder. So you are getting this, and you go to step 6. So that is, you have to repeat these steps 7 through 9 until the remainder is 0. If the remainder is 0, you will straight away come to step 10 and print the value of the GCD. What are the two numbers that has been taken, as well as the present GCD also. The program for this is this. So because we are going to find the GCD between two integer numbers, you are saying input, enter the first number and store it as A. So it is integer, so int within bracket input, within the quote sign, enter the first number. Similarly, you read the second number and store it as B. INT, input, enter the second number. Now, numerator becomes A. So that is, you are storing the value of A as the numerator, value of numerator. And similarly, value of B as the value of denominator. You find the remainder, which is numerator percentage denominator, you will get the remainder. You have to repeat the following steps if the remainder is not equal to 0. What do you have to do? Previous denominator has to be stored as new numerator. Previous remainder is stored as denominator. Now you find the remainder based on the numerator percentage denominator and you repeat these steps. When remainder becomes 0, you will come to the next step, which is GCD is equal to denominator, and you will print the value of A, B and C GCD. So this is the program for finding the GCD of two numbers. It is simple for programming. It's easy to computerize rather than finding the prime factors and then finding the GCD. Now, if you want to find out the GCD between n numbers, any number of numbers, let us take 2 at a time and then find the GCD. So that is, first find the GCD between first two numbers, then you take the third number as the GCD of the first two numbers, and then find the GCD between this GCD and the third number, and then like that for fourth number, fifth number, like that. Each and every time you find a GCD between two numbers and add it to another number, and then you compare that. This is the procedure that can be used to find the GCD of any number of numbers. If you are trying to find out the GCD between the numbers 24, 18, 72 and 36, first what we have to do is we have to find the GCD between 24 and 18. Now as I said, we take 24 as the numerator, 18 is the denominator. So if you divide 24 by 18, quotient is 1, remainder is 0. Whether the remainder is 0, no. Then in that case, previous denominator 18 is taken as the numerator and the remainder is taken as the denominator. 18 by 6 will give the quotient as 3 and the remainder is 0. So since the remainder is 0, the GCD between 24 and 18 is 6. Now what we have to do is we have to take the third number, which is 72, and the other number is going to be the present GCD. So between these two we have to find out the GCD. Okay. So now the numerator is 72. The denominator is a previous GCD, which is 6. So if you divide 72 by 6, once again the quotient is 12 and the remainder is 0. Since the remainder is 0, up to the third number, the GCD is going to be 6. So this has to be repeated with the fourth number, which is going to be your 36. So GCD up to previous three numbers is 6. Now the fourth number is 36. You take 36 as the numerator and denominator is 6. That is the previous GCD. Now you divide 36 by 6. So you get the quotient as 6 and the remainder is 0. Now since the remainder is 0, we are going to have the GCD as 6. Like that, we can compare with any number of numbers and find the GCD. Let us modify this two-number program itself so that it can be extended for any number of numbers. Not much of difficulty is going to be there in finding the GCD. Now, for that, what we are going to do is, if you want to find the GCD of more than two numbers, the following procedure has to be followed. That is, read all the numbers and store it in a set. Normally we call it as array in a normal procedure. In Python, we call it as a list or a tuple. Let us assume it is stored as a list. Now, here you assume the first number as the GCD. Take this GCD and the next number if it is available. Because why we are putting that word if it is available is, when you are reaching the last number, after that nth number if you are taken, there won't be any new numbers. So in that case, if it is available, only if it is available, then find the new GCD between the two numbers, that is the GCD and also the next number which you have taken. These two numbers, if any more number is available, this new GCD is stored as the GCD, and you will be taking the next number and repeating this operation. Okay, this is what is done if you are going to have more than two numbers. Let us first write the program for finding it in two numbers, and then how it can be extended. This. Now here I have defined S as a list. It's an empty list. So I am reading a first number, as in the earlier case, integer, input, enter the first number, and I am appending to the list S. Then similarly, I get the second number and store it as B, and this is appended to the list S. Now S is having two elements where the values are A and B. But when we want to refer the number which are stored in the list, the subscript of the list starts from 0. The first element is stored as the 0th element. Second element is stored as the first element. Therefore, we have to simply do some, that point has to be remembered when you are writing a program using list. So therefore, I am taking GCD as S of 0. So whatever is stored as the 0th element, that is stored as the GCD now. And the next element is taken as the denominator. Numerator as S of 1. Now, as I already said, whatever is the previous GCD, that has to be taken as the denominator now. That is why numerator is S of 1, denominator becomes GCD. Because why you have taken this portion we are going to repeat. Whatever is coming after this, these are going to be repeated if there are going to be n numbers. That is why we are writing it in two different times. GCD is equal to S of 0, numerator is equal to S of 1, denominator is equal to GCD. We are not writing it straight away S of 0 because each and every time you are going to compare with a GCD of a particular number with the next number. Like that we are going to compare. So now, as you have assumed numerator as S of 1, denominator is equal to GCD, you can find remainder is equal to numerator percentage denominator as we did in the last case. So we will be getting the remainder. If it is 0, you will get straight away come to GCD as the denominator you store and then print. If it is not equal to 0, as we have done in the previous program, we are going in numerator is equal to denominator, denominator is equal to numerator, remainder is equal to numerator percentage denominator. Now, what is the difference between this program as well as the previous program? In the previous program, straight away you have used numerator as the one value, denominator as another value, and then you were repeating it. Here, we are first storing it in a list and then taking those two elements and then doing it. So one element is, first element itself is assumed GCD once it is read, and then when you are taking the second element, now the already assumed GCD will become the denominator. Now you are performing this. You are finding the new GCD between the new number as well as the previous GCD. This has to be repeated. That is what is done here. So if you want to extend this to any number of numbers, what you are going to do? First step is you have to give how many numbers you are going to give, among which you have to find the GCD. Whether we have to find the GCD between two numbers or three numbers or 10 numbers, that we are going to give, and you are going to read that value as n. That's what step 1 is. Input the value of number of numbers whose GCD has to be found out and store it as n. Now what is step 2? See, once we are doing that, we are going to add those numbers. N numbers you have to read and then you have to put it in the list. That's what. Repeat step 3 to step 4, varying the value of I from 0 by 1 until I is equal to n. That is, input a number and store it as x. What you are going to do? You are going to repeat the steps 3 and 4. That is, you will be repeating a number, inputting a number and store it as x, and then add this value as the ith element of array yes, or set list yes. Why I am doing that is, as I said earlier, here we are going to have it as element, each and element has to be stored. See, you are going to, in a list, you are going to store it as from 0th onwards. That is why the value of I varies from 0. So when it is 0, you are reading the value of x and storing it as the 0th element of array x. Yes. Then when it comes to step 2, it is increasing a value of I by 1, and it reads the value and store it as first element in S, that is ith element of array S, first element in X. Then 2, 3, like that. When it becomes equal to n, it will come out of the loop and it will go for step 5. What is step 5? Now, as I said in the previous case, when the previous example we have seen, the first 0th element is assumed as the GCD. That is what is done here. Store the 0th element of array S as GCD. Then repeat step through step 14, varying I from 1 by 1 until I is equal to n. Till I becomes n, we are going to repeat the values. State the next number, next number, next number. Once I becomes n, it has to come out of the loop because we are starting from 0 onwards. See, the 0 element is taken. If there are 10 elements, the first element is stored as the 0th element, so it has been taken. So we have to take, there are only 9 more elements are available. The value of n is 10. So once I becomes 10, you have already taken all the things, so you have to come out of the loop. That is, you have to go for step 15. Now what we are going to do from between step 7 and 14? Now you are storing the value of ith element of array S as the value of numerator. That is, the new element is stored as the numerator, and whatever is stored as the GCD, that is stored as the denominator. That is step 8. Now you divide this numerator by denominator and get the remainder. So you will be getting the remainder. So what you have to do? You have to repeat step 9 till you are going to get the value of denominator 0. So step 10 is repeat step 11 through 13 while the value of remainder is not equal to 0. So what you have to do here? The value of denominator is stored as the value of numerator, and the value of remainder is stored as the denominator. Now you divide numerator by denominator and get the remainder. So this step has to be repeated. That is 11, 12, 13 has to be repeated till remainder becomes 0. That is the GCD between old GCD as well as the new number has been found out. This step 11 through 13 has to be repeated. Now this value is stored as the value of the denominator. Once you come for step 14, now you come back to step 6 now. So here, once again, you increment the value of I by 1, and if there is any, if it is not equal to n, now you take the next element and repeat the procedure. Like that you will be doing all these things. Once you finished all these things, you will output the list or the array, or it is called, even though it can be called as an array also, array S as well as the GCD. This is the method of finding the GCD of n numbers. So here n is equal to integer input, enter the number of numbers. S is a list, empty list. So for I in range, I am using a for loop here. For I in range n means I will assume a value 0, 1, 2, 3, etc. up to n minus 1. Once it becomes n, it will come out of the for loop. It will come to GCD. So here x is equal to integer input, enter a number. You are appending the value of x. So it is repeated. So it is repeated and stored in the array list S. Now you are taking GCD S equal to S of 0. Now for I is equal to for I in range 1 comma n. So because 0th element is taken here, you have to take 1 to n minus 1. So once it becomes n, it will come out of the loop. It will simply print this. Now what you have to do here? The ith element is stored as the numerator. This old GCD is taken as the denominator, and you are finding the remainder. If the remainder is not equal to 0, we are replacing the numerator with the denominator value and the denominator by the remainder. You are finding the new remainder. This loop is repeated till you find the GCD between the ith element as well as the previous GCD. Once your remainder becomes 0, you come here, GCD is the denominator. Now, where you take the next element is taken, so the next ith element is taken. I is incremented by 1 and that element is taken and it is assumed as the denominator. Whatever you have found here as GCD, that will be stored as the denominator. This has to be repeated till you take all the elements as in the GCD. So this is a common program which can be used for 2 numbers, or it can be used even for n numbers. There is no limit on that. It is a generalized one. So like that, we can find the GCD of 2 numbers as well as any number of numbers. Thank you one and all. We will see once again later.